Let's continue now on the Gram-Schmidt and how to calculate the R matrix during the Gram-Schmidt process. We are given A, which is m by n, and this step is the step to construct the orthogonal columns in V1, V2, V3 that spans the same space as x1, x2, and x3. We then added a step to perform octonormalization, taking the columns of V1, V2, dividing it by their norms so that U1, U2, and Ui are octonormal columns spanning the same space as V1, V2, and Vi. We would now use this U1, U2, and Ui to form Q matrix. So now you realize that the Q matrix are formed by these two processes. First, orthogonalization, followed by normalization. Once you have the Q matrix U1, U2, and Un, then you realize that QTQ will be equals to I. We are now ready to find R. To find R, actually because we started with A equals to QR, we have columns of A, we have already columns of Q. How do we form R? So this is how we form R. For example, the first column of x1 is formed by using U1 and U1 dotting with x1. This value is R11. What about forming x2? x2 is formed by using U2, U1 dot x2, U2 dot x2. We can then continue this process to find all these constant multiplying by the associated U1, U2, and U3. You realize that this equation is very simple because the U's are normalized to with length 1 and they are orthogonal to each other. In matrix notation, the R11s, R12, R13 are extracted in this form. R22, R23. So you realize that if you can now interpret A equals to QR with these coefficients, you would get this equation. To have a concrete example, let us now perform a Gram-Schmidt decomposition on the 3 by 3 matrix. So A is square, and in this example, A has independent column, and then if A is 3 by 3, Q would be 3 by 3, and then R would also be 3 by 3. Okay, so please proceed to work this out. First, we find the orthogonal columns, followed by the normalization to get the octonormal columns for Q. And then you work out each of these individual elements such that QR is equals to A, using the equation we have over here. Okay, that's it. Thank you.